Good morning, student. Let's start today's class. Today we'll discuss about that the process which happened inside the solar cell, okay, when the light irradiation or the solar cell with light irradiation. That means when the solar cell is exposed to the sun radiation. Okay, irradiation means the the solar cell is exposed or shown to the sun radiation, or in simple way, when the sun is ready or sun ray is incident on the solar cell, what happened inside the solar cell, or which process will happen inside the solar cell, that we discuss here. Okay, the solar cell, okay, this is the solar cell, and this solar cell have three region. You see, this is one region, this is one region, and this is one region. The first region is a strongly end-doped diffuse emitter. This one, okay, first this one, upper one, okay, this is emitter and n-type n-type semiconductor, okay, and the second one, this middle one, is space charge region, okay, and the third one is p-type or basis or p-doped basis, okay, or p-type semiconductor, okay. Then what happened when this is sun radiation, when sun radiate through the emitter, transparent emitter and space charge region, and reached to the uh, basis or p-type p-doped basis, then the sun radiation absorbed here in p-type, and the and the and a electron and hole pair generated, okay. When the p type semiconductor absorb the uh, or absorb the quantized light or the charged photon from the solar radiation, the electron and hole pair generated, okay. Then after that, due to the electrons are in minority carrier in the p-type semiconductor, since in p-type carrier, p-type semiconductor, the minority carrier is electron and the majority carrier is hole. Minority carrier means the number of electron is less, and the majority carrier means the number of number of hole is high, okay. And that electron diffused or transmitted through the traveled through the p-type semiconductor, okay, this p-type region, and reached at the border of the space region, space charge region. Here it is here this, let's say this electron here reached at the border, okay. Then what happened, due to the this in space charge region, this is the charge region or the electric field region. Due to this electric field region, this electron, okay, this electron can jump to n-type region, okay. This electron attract or jumped or attract by this uh, governed electric field, okay, and get and reached at n-type region, okay. Similarly, when the n-type emitter is absorbed sun radiation or photon, then here the here the minority charge is whole, okay. Then that hole which is positively charged, okay, this positively charged, and that hole is traveled in the emitter side and reached at border of the space charge region, and due to the electric field in the space charge region, this hole can jump to the p-type region, okay. That means here, due to the field or the electric field or the charge field, this electron can the electron from p side can jump to the n side, and the hole in the n side is jumped to the p side. Okay, so due to this, so so from this we clear that due to the presence of space charge region in p junction, electrons migrate to n region and hole migrate to p region. Okay, so there is an excess of electron in n region. Okay, since in n region, okay, or n type semiconductor, there is so many electron, or that is the majority carrier is electron, there is so many electron, and again the electron migrated from p type to p region to n region. So there is an excess of electron. Similarly, in the p region there is deficiency of electron, that means excess of hole, that is equal to that hole means deficiency of electron. Okay, or the blank place where the electron lived, that blank place is called hole. Okay, so excess hole means deficiency of electron. Okay, so if you see in n region and in p region there is excess of, in n region there is excess of electron. Okay, but in p region there is shortage of electron. So when we connect this n region through a wire and a load, okay, to p region, then the current or charge flow to from p n region to p region, and the flow of charge, due to the flow of charge the current will transmit. Okay, so when we connect n region and p region through a conductor and a load, the generation of voltage by charge separation will happen. Okay, in the place of dopant p-n junction diode, we can use Schottky diode or heterodiode or metal insulator semiconductor diode. Okay, here we use in the solar cell p-n junction diode, but we can use Schottky diode, heterodiode and metal insulator diode in the place of that p-n junction diode. And Schottky diode is what? A Schottky diode is made of semiconductor on the surface of a thin metallic film which is deposited through high vacuum deposition technique. Okay, this Schottky diode is deposited on a film thin metal film, uh, and it is deposited in in high vacuum deposition technique. Okay, the main difference between the normal PN solar cell and the Schottky solar cell is that in latter the electric field region reaches up to the upper surface of the semiconductor. Okay, and next is metal insulator or semiconductor, metal insulator semiconductor diode. Okay, in Schottky diode tunnel, sorry, this is tunnel, this correct it, this is T, tunnel, tunneling solar, tunneling loss of electrons are there. Okay, in Schottky diode there is a problem which is called tunneling loss are there. Okay, to overcome this problem we inserting a very thin layer of insulating material, or that is 2 to 4 nanometer thickness between the semiconductor and the metal. Such type of solar cell is then called metal insulator semiconductor. That means in Schottky diode what happened, there is a metal thin metal film and upper that directly semiconductor deposited. Okay, in the fabrication process of the semiconductor we can see the that process, this fabrication process is here also happened. Okay, in a thin thin conducting film. Okay, but here the problem is that here the tunneling loss of tunnel or the electron losses due to the tunneling effect. Okay, so to overcome that we can this thin flame, after that thin flame one insulating layer is there, and again the in semiconductor deposited. Okay, this process will, or this type of diode is called metal insulator semiconductor diode. Okay, thank you.